Okay, we're down to the last operation, and that's division. For some people, division seems to be really challenging, and that's mostly because there's probably more steps in it. And when you're doing long division, you're actually adding in the operation of multiplication as well, and subtraction. So it's kind of a multi-step kind of thing. You know what I mean? Like, for instance, if I have a number like 275, and I want to divide that by just 5, let's keep it kind of simple. If you remember the rules of divisibility, you basically know that 5 can go into 275 because 275 ends in a 5. So we know we're going to get a nice even number. So let's go over the steps. Let's just do a quick review. I can rewrite this as this. The number that I'm dividing goes under the bracket, and the number that I'm dividing by goes outside the bracket. Because basically, the whole point of division is to try to figure out how many times does this fit into this. And the answer will be how many times this did fit into this, okay? So, we always start from here. The two numbers that are closest to each other, we ask ourselves as we're going, does 5 divide 2? In other words, can 5 go into 2? And the answer is no, because 5 is bigger than 2, so that doesn't make any sense. So instead of looking at the 2, I expand my vision to 27, and I ask myself the same question. Does 5 go into 27? Can 27 be divided by 5? And in this case, that's possible, absolutely. In fact, if I go through my multiples of 5, there's 5, 10, 15, 20, 25. So I know that 5 goes into 27 5 times. Not 6, because 6 times 5 is 30, and that's too big. Okay? So 5 times 5 is 25, which I'll write right underneath the 27. And now I have subtraction. 27 minus 25 is 2. Okay, so I'll write the answer to that subtraction problem there. And since I'm moving more to the right, I'm going to go ahead and bring this guy down here and make this a 25. And then I ask the question again. Can 5 go into 25? Can 25 be divided by 5? Yeah, evenly, right? 5 times 5, I just figured that out. So I write the answer above that number. 5 times 5 is 25. And I know that I'm done because I've used up all the digits in this number and there's no remainder. So this right here is the answer to the question, how many times can 5 go into 25? 55 times. And I can always check that answer by multiplication, which is just backwards, right? Backwards division. Is 55 times 5 275? 5 times 5 is 25. Carry that 2 over there. 5 times 5 is 25, and add that 2. That's 275. So we're in good shape there. This is something that you've probably seen before. Generally, long division like this is a 5th grade, sometimes a 4th grade skill. In 6th grade, we start talking about what happens when we put decimals into this. Okay? Now here's a funny question. How many times can 5 go into 2.75? Ooh, that sounds weird because didn't we just say that 5 can't go into 2? So how does it go into 2.75? Let's check this out. Let's go ahead and just keep it like we did, okay? 2.75. Now we just kind of talked about how we can't make 5 go into 2. But we still have all these digits right here, and we can work with those, okay? So let's ignore this decimal just for now, all right? Pretend it's not there. Don't let it distract you. Let's just keep doing it the way we did before. So we expanded the division out to 27, and that we decided that 5 goes into 27 5 times, which gives us 25. And if we subtract that, we get 2. Next step, bring down the next number next to our answer, and we know that 5 goes into 25 5 times. which is how we finished, with no remainder, okay? But there's still a decimal here, okay? Which goes straight up. So this isn't 55 anymore. This is 0.55. This is 55 hundredths, all right? That means that 5 goes into 2.75 less than one time. In fact, it goes in there 0.55 times, okay? Conceptually, that's a little difficult to grasp. But the question can also be asked, can 0.55, and I'm going backwards here, can 0.55 fit into 2.75 5 times? Okay, so if I took a measurement and something was just over 1/2 of an inch, it was 0.55 inches. And I said, okay, well, that's a piece that I'm gonna need, but I need it 5 times longer than that. How many inches is this gonna have to be if it has to be 5 times longer than just over 1/2 an inch? And if I multiply that out, because we just did multiplication of decimals, so we're experts already. 1, 2, 1, 2. I'm gonna have to measure out 2.75 inches, okay? So this is conceptually what's going on here. It looks weird at first, but it actually does make sense, okay? Let's look at something else. This is division of a decimal by a whole number, okay? And we used the standard algorithm of long division to come up with an answer. What if my decimal wasn't at the 275, what if it was actually here? What if it's 275 divided by 0.5? This time, I'm trying to figure out how many times does a 1/2 go into 275? Because 0.5 is a 1/2, right? In fact, any decimal with a 0 here is less than 1. So we're trying to figure out how many halves can fit into 275. Let's set that up. Okay. Now here's something kind of weird. Before, I had the decimal here, so I could just shoot it straight up and that would be part of my answer. But this time the decimal is way over here in the number that I'm trying to figure out how many times does it go into this number. So we're gonna change this, okay? Since this is basically a fraction, this is basically 275 over 0.5. And since fractions generally don't like decimals, we can do a little trick here, okay? We can multiply both of these by 10. And why 10? Well, because when I multiply this bottom number by 10, it's going to turn it into a whole number, okay? If I had 0.55, that's 2 decimal places, so I'd want to multiply that by 100 to get it to be a whole number, but it's only 1 decimal place. So conceptually, and this isn't something you're going to have to think of every time because I'm going to show you a shortcut, but what's happening basically over what I'm about to do here is that I'm multiplying the top and the bottom of this fraction by 10, so it comes out as 2,750 over 5. I multiplied the top and the bottom by 10, okay? Over here, with the shortcut that I'm going to show you, here's what it looks like. I'm going to move this decimal place 1 space so that this becomes a whole number, because dividing by a whole number is much easier. And this decimal that doesn't show up but we know is there also moves 1 space over, and we fill it in with a 0. See how this and this become kind of the same thing? Okay? So just to clean it up, I'm going to rewrite it one more time. It now looks like this. And now it's just straight division, right? Let's figure out how many times a half goes into 275. 5 doesn't go into 2, but it does go into 27 5 times. We've already done this, so I can go a little faster, I think. 5 goes into 25, also 5 times. This time we're not quite done yet, because we do need to bring a 0 down here. 5 doesn't go in, 0 divided by 5 is 0. So, a half can fit into 275 550 times, okay? The trick is knowing that if you have a decimal out here, to move it over enough times so that you have a whole number. And that's just because we're multiplying both parts of this division problem by enough of a 10, that could be 10, 100, 1,000, 10,000, to get it to be a whole number, okay? Let's try one more practice with moving that decimal over. Again, with numbers that you're probably not gonna see in everyday life. But when you get into the higher math or into the sciences, you'll start seeing numbers that are weird like this. Let's say that we have 47.3. That could be some measurement we took. And we're going to divide that by 0.49. That's almost a half, but it's a little more precise, okay? So it's almost the same question as last time. How many times does 49 hundredths fit into 47.3? Now this time I have decimals in both numbers. Let's go ahead and rewrite that underneath the division bracket and this number on the outside. And before I move on, what's next? What am I trying to get here? If I were to rewrite this, what would it look like? If you need to pause the video and play around with this a little bit before I go on, do that now. Okay? So I know I want this number to be whole. I don't want it to be a decimal anymore, which means I'm going to have to count how many spaces I move this decimal over to the right to make 0.49 a whole number. I can do 1, 2, so that the decimal is sitting on the very right of this whole number, and that gives me 49, right? But as with any ratio or any fraction, if I do that to one part of it, I have to do it to the other side. So if I move this decimal point 2 spaces to the right, I have to do the same thing to this decimal point. 1, 2. And there's an empty spot here, which I can fill in with 0. And if I rewrite this number, instead of 47.3, I actually have 4,730. And now I have a division problem I can work with, okay? 49 can't go into 4, obviously. 49 doesn't quite fit into 47, but 49 does fit into 473. How many times? Let's think about that. This is a very big number. If I multiply 8 times 4, I'm going to get 32. Let's try that. Let's try 8. Does 49 go into 473 8 times? Let's find out. 8 times 9 is 72. So I give the 2 right here and carry the 7 over here. 8 times 4 is 32. 32 plus that 7 gives me 39. I don't think I can use 9 because I'll get bigger than 47. So let's go ahead and subtract this. 3 minus 2 is 1. 9 can't come out of 7, so let's borrow 100 from over here and give it here. 17 minus 9 is 8, and 3 minus 3 is 0. 81. Now here's a trick. Can we use 8? Let's see if you learned this in some other school. If this number is bigger than this number, then this number is not big enough. Okay? That's a nice little learning opportunity there. If you're done subtracting here, and this number right here, your answer is too big, it's bigger than this number, that means this number is not big enough. So we should have actually used 9. Let's change this to 9 and do that multiplication over again. 9 times 9 is 81. Oops, I gotta get rid of this. There's the 1, carry the 8. 9 times 4 is 36, and 36 plus that 8 is that right? 32? No, 44, sorry. 36, 44. Okay. 3 minus 1 is 2, 7 minus 4 is 3, and 4 minus 4 is nothing. Now this number is smaller than that number, so I can keep going. Bring this 0 down. 4 does go into 32 8 times, but this 9 is going to push me up over that. So let's go with 7. 7 times 9 is 63. Carry the 6. 7 times 4 is 28. 28 plus 6 is 34. Is that right? Yeah. Oh. That's a bad sign right there too. These are things where you're actually going to check yourself before moving on. So 7 was too big because this number is too big. I can't take 343 out of 320, right? I'm just going to check my multiplication one more time. 28 plus that 6 gives me 34. So I know I did my math right, but this is too high. Okay. Let me replace this because I erased it for some reason. Okay, so 7's too high. Let's go with 6. 6 times 9 is 54. Oops. Okay, carry that 5. 6 times 4 is 24. 24 plus 5 is 29. That's a much more friendly number because it's smaller than that number. So let's just do the subtraction. $26. Okay. Now I'm gonna have a decimal here, and I'm gonna go ahead and round this to the nearest whole number actually, because we don't need to spread out into decimals for this example. Let me go ahead and add one more. Does 49 go into 26? Let's go with 5 times. 45. Carry that 4. 5 times 4 is 20, plus 4 is 24. So this number right here is going to tell me to round that 6 up, and I'm going to say that this is approximately equal to 97. Okay? Now again, you're not going to see numbers like this in my exercises. You will see more examples like this in the higher sciences and the higher maths. And I have a little secret for you. You're going to be using a calculator anyway. But I want to make sure that you're okay conceptually with why we do this, okay, and how it works. Whenever you see a decimal here, you're going to have to turn it into a whole number. And however many times you move that decimal, you must do the same thing to the number inside the brackets, because that's how fractions work. Now the answer to this came out to be about 97, which means I can fit 0.49, which is just under a half, into 47.3 about 97 times, okay? And this long division right here was quite messy. But it's good to practice it over and over again. Even at my age, even with my experience teaching math, this is a good exercise for my mind so that I can check and try and make sure the algorithm works and all that good stuff, okay? Now, I promise the exercises underneath this are much easier, but you're also gonna be looking at some word problems, all right? So, read through them, think through them. If you need help, go back to the introduction to math and download the problem solving guide. Kind of gives you some extra little helpful tips there. And try those exercises. Try not to use a calculator for these, not yet. And when you're done with the exercises, which are both multiplication and division, go ahead and go to the video underneath it and we'll go over them together. Okay?